So today I am going to explain you this question of determinant. Here we have to prove that this determinant x square y y square zx second row, z square xy third row as equals to x minus y minus z minus x and this bracket xy plus yz plus zx. So if you observe the left hand side carefully and right hand side, so in right hand side there is bracket x minus y minus z minus s. So for that we'll try to get x minus y and y minus z as terms. So when we consider the left hand side, consider the left hand side of this determinant. It is the determinant, and then x minus y. For x minus y, x is in the first row, y in second row, so we'll do the row transformation. X minus y, for that we need r1 minus r2. So we'll do this row transformation first, r1 minus r2 4. Okay, so here this term will be x square minus y square. We can apply the formula. Yz minus zx, we can take z common. Okay, similarly r2 will changes to r2 minus r3. So when we do r2 minus r3, we'll get y minus z here, then y square minus z square and zx minus xy. Here we can apply the formula again, and here we can take x common. Okay, so our row transformation will be r1 changes to r1 minus r2, then r2 changes to r2 minus r3. In the same step we can do both the row transformations. Okay, so I have written this after row transformations: x minus y, then x minus y, x square minus y square and yz minus xz. Similarly the second row we get. Okay, third row will remain as it is. No need to change the elements of the third row because we are doing the transformations on r1 and the r2 rows only. Okay, so x square minus y square, I am writing the expansion here, x square minus y square, the formula x plus y x minus y, and y square minus z square. So y square minus z square, then y plus z, y minus z. Okay, so these are the brackets of this expansion. So easily we can say that x minus y is common in the first row and y minus z is common in the second row, because here also we are getting, but here we get y minus x, so be careful. So we will take minus z common, and in the second row we'll take minus x common so as to get y minus z bracket. Here we'll take minus z common so that we get x minus y as a common bracket. We can take x minus y common. So taking x minus y common from r1 and y minus z common from the second row r2. So I have taken x minus y, we will write outside the determinant over here. So x minus y and y minus z, these are the two brackets common from first and second row. So the elements which are left here, we have taken x minus y common, so here we can write 1 will left. From this is the product of x plus y x minus y. We have taken x minus y as a common bracket, x plus y will left, and from this we have taken minus z common, and x minus y, this bracket will left, that is common. Okay, so minus z will left. Similarly the second row will be 1 y plus z minus x. Okay, 1 y plus z minus x. Keep the elements of the third row again as it is. No need to change the third row. So we get x minus y, y minus z. These are the required brackets. Okay, now we want z minus x. Okay, z minus x. For that, see, z minus x, or we will try to get this 0 also. When we do again, r1 changes to r1 minus r2. Then automatically 1 minus 1, here we get 0. Then x plus y minus z, we can cancel x minus z will left, and here minus z plus x, that is x minus z again. Okay, so I am doing r1 changes to r1 minus r2. So r1 changes to r1 minus r2, this term will be 0, this is x minus z, this is also x minus z, but we want the bracket as z minus x, so we will take z minus x common. Here minus 1 left. Okay, so x minus z, that is z minus x is common, and x minus y minus z, and z minus x, these are our required brackets. And here this is 0 minus 1 minus 1, because we have taken z minus x common, so here we have to write minus 1. Okay, so 0 minus 1 minus 1, 1 y plus z minus x, and z square xy. Okay, and now either you expand this, or again I have done c2 changes to c2 minus 3 c3, c2 minus c3, so that to get 0 here. Okay, so minus 1 plus 1, here we get 0. Okay, and the calculation will be easy. So c2 changes to c2 minus c3, these are the brackets, x minus y minus z, z minus x. And now there will be the change in c2 column, c1, write down the column c1 as it is, and c2 column will be minus 1 plus 1, here I have written 0, this will be y plus z, and minus of minus x, that is it becomes x, and z square minus xy, this is the third element of c2 column. And write the elements of c3 column as it is. Now children, here we have done the rows as well as column transformation in the same question, we can do that. Okay, so now we get two zeros. Now easily we can expand this determinant. Okay, so it will be 0 into this 0, then 0 into the second determinant 0, and then minus 1 into these terms, z square minus xy, and minus zy, then minus z square, and plus minus zx. So these are the terms. After solving this, there we can cancel this z square and we get the remaining bracket. So these are the terms. After expanding, we get x minus y minus z, z minus x. These two terms, first two terms are 0, and the last one is minus 1 into this expansion. So z square and minus z square will get cancelled. All these terms are negative here, but there is minus 1 before the bracket, so change the sign of the terms. We get xy plus yz and zx, okay, plus zx. So that is our right hand side. So this is equals to RHS. So in this way we can solve the required, we can get the required right hand side over here.